So this is what happens now, guys, when we played the simulation, and as you can see, it's not working fine. So here in the signature, we can set it to primitive name and type velocity. And if we play now, you'll see our smoke is following our curve now, which is really great. Now we can just increase the resolution of our simulation to something like this. And yeah, our smoke is now working, which is really great. Maybe in our sphere here, we have this division size. We can set it to something like this. And now if we press play, our smoke is working, which is really great. We can promote this parameter here, guys, the 4. Think we can call it max distance of mix, maximum distance of velocity blend, maybe velocity blend. Okay, yeah, I think this name is a little bit intuitive. You can choose the name you want. Now, guys, we can here in the gas field VOP set this input to grab our curve from our sub guide, and here we are going to open a point cloud. Now we are going to select the position of the voxels and our curve points. Now we have our curve points. We can set the search radius to 0.5, and now we are grabbing the points from the curve. Okay, maybe we can go here in the sub guide and copy this maximum radius and paste relative reference here so they match with each other, and we can grab the position of the points of our curve. So now we are just doing the same thing that we did in the SOPs. We are grabbing the position of the curve points that are near to our voxels. Okay, and we can do a subtract between the position of the voxel and position of our curve point. And this is the same idea. We have now the distance between the curve points and the position of our voxels. So it's just the same idea that we did here. Okay. And we can take the length of this. Now we can control our velocity blend depending on on how far the density field here or our simulation smoke from the curve points. the same idea. What we can do, we can just create a fit range node, okay, and in this fit range we can, here in the source max, we can paste our maximum radius, okay. So we are now controlling the simulation around the curve within the maximum radius here, and we can now set it from 0 to 1, for example, like this, and we can add another mix node, and we can connect this, okay. So now we can control the smoke based on the distance between it and the curve. So if it has a distance between it and the curve of 1 or more, okay, we want this far smoke to follow the velocity of the simulation. We want it to be affected by the temperature and the buoyancy. This will make it more natural as it's going to float, you know, and it will not adhere to our curve. And this is going to be great because this smoke here will be naturally floating. It's just a smoke. We don't want it to be very, very sticky to our curve, and we want the far smoke to float upwards, okay. And if it's not far or it's near to the curve, we want to use this velocity, and we can now connect this to our velocity. And if we now play our simulation, so now here is our simulation. What we can do now, we can just here inside, we can scale our orbit force. We want it more, okay. And we need to add some noise to this simulation. To do this, we can add a gas turbulence node, the basic node here, and can make the scale something like 1. And now if we play, now you will find the far smoke is more natural and less sticky to the curve. We can also make the swirl size 0.1, make the scale something like 3. We can also here in the buoyancy, we can increase our buoyancy to 10. And you'll see more natural effect here. Maybe we can just here, let's make the swirl size something like 3. Scale, let's make it 10. I just want to show you guys. I think 10 is too much. We can something like 6, for example. Still too much. We can use stick to 3 again. And here is the far smoke. It's going to float away. As you can see, it's not going to really match the curve, which is really great. If you see here in this area, it's floating away. I just wanted to show you guys, but the scale surely is too much. So I'm going to stick to 1. And what we can do now, if we, for example here, set this to 0.5 and play my simulation again, you will see that it will stick more to the curve. Okay, because this means when the distance is, if the distance is 1 or more, it's going to put 0.5 here in the mix, so it's going to be between the input 1 and the input 2. Okay, it's not going to be purely our smoke velocity, so this is going to make it stick more to the curve. If we set it, for example, to 0.1, it's going to stick much more to the curve. So what we can do, and make this one again, what we can do, we can just promote this parameter, and we want our user to control the curve thickness, curve thickness. But the problem now, if the user sets the curve thickness to 1, we will have here 1, okay, and this will make it float more, or it will make it this will make it less sticky, okay. And to avoid this, we can create a complement node. So now when the curve thickness is set by the user to 1, the complement of 1 minus 1 is 0. Sorry, so when the user sets the curve thickness to 0, okay, it's going to the complement of 0, 1 minus 0 is 1, and here this is going to input a value of 1. So now the user is going to control the curve thickness, and we can set the default value 0.1. So 1 minus 0.1 is 0.9. So now we are going to have this number here, 0.9. Okay, and I don't know why it's just like this here. Let me, yeah, I think it's working now. So now we have a parameter to control the curve thickness, and we have something like this now. Let me flipbook it and show you guys, but before this we want to show our simulation better. So I'm going to create a geometry node and import my simulation here. So I'm going to add the DOP import fields. The DOP network is going to be this DOP network. Our object is going to be our smoke object. I'm going to take this appraise smoke and add a volume visualization node. Okay, we can put the maximum resolution and the density scale to 10. Okay. And let me add some lights. I'm going to hide this now. You'll add lights like we did before, and add a spotlight here. For example, we can make the exposure larger, something maybe like this. We can make it yellowish. We can add another one here. Can make it more blue. And maybe in the import here, we can set the shadow scale to 1.2. Okay. Maybe we can add another light from behind here. Can add a spotlight here again with less exposure, something like this. And we can create a camera. Okay, we can also go to our DOP network and increase the resolution, something like this, and in the gas turbulence. Okay, I think it's enough for now. Now let me flip book the simulation and show you guys. So now guys, here is our simulation, and as you can see, the smoke that is far is going to create interesting shapes, and this is really great. Now the last thing guys I want to show you, you can just create an OTL here and call it curve force, and I will show you guys my OTL, but you'll just edit the parameter interface and go to the sub guide. You can grab whatever you want from here, and then here in the gas field bob you can grab whatever you want from here and create your OTL. I will leave this for you guys, but also sorry, don't forget to add the show guide geometry here, which will show your curve, and don't don't forget to put the display flag here in the volume trail. So if you now play, my viewport is very buggy, so now it's going to show you your guide geometry, and here we go. So now I will show you my version, because if I create it now for you, it's going to be very boring, and we did this a lot before, just grabbing the parameters, putting them. So this is my version. Here we had this geometry source, which is the object merge object here, okay? Because we can select any curve that we create from this, and we have the maximum radius, the curve's thickness here in this tab, curve force, and we created these parameters, and we also may put here the maximum distance of velocity blend, and here we have the tabs for every force, for the flow force, follow force, the orbit force, the suction force, and inside every tab we have the scale of this and the ramp, the distance between it and the curve between and we have the ramp here, the follow force from curve ramp that we created, and the same for the orbit and the suction. And here we have the global force where we have two ramps that we created, the from curve ramp and a long length ramp. And as I told you, we can create also a long length ramp for all of these forces. And we also had this shaping here. If you remember, we created here this ramp here, a long length radius ramp, and also we have the resample here. We can take this resample length. So this is what I did here, the resample length and the radius along the curve. The radius along the length here. And we had our geometry here, the show guide geometry, and the trail length is just this length here in the volume trail, which can increase or decrease your trail length here in the viewport. And this is it. You can just start putting the parameters like this. This curve force is just a folder with the forces inside it, and we have another folder here for the guide. I encourage you guys to create your own version because I don't want to lengthen the videos with something that we already created before. So this is how you can create a curve force. Of course, you can use this in any particle simulation too, but you will just use a node called pop advect by volume, and we will talk about particle simulations. So now let's apply the curve force here in a pop network. Okay, so this is just a pop network. You can just create it from here, source from object, source particle emission, and you can create it yourself by creating a pop object, a pop solver, and this pop source you can just connect it here to the sourcing. And this pop source in this pop source you select a geometry. So I choose my sphere here. Okay, and you can emit from the sphere. So I just chose my sphere, and I here in the attributes set the initial velocity. I gave it a value of 111. So this is what we have now. We have particles going in every direction here, and I want to apply my curve force here to the particles. So we can do this by putting a merge node here. Okay, let me hide the guide geometry. Okay, then this is my curve force, and if we play, nothing will happen, because if you go to the spreadsheet here, you will find that the pop solver doesn't deal with fields. It does not create the velocity field, the density, and all of this stuff. It works with the particles as points only, and it does not work with fields. Smoke solvers and pyro worked with fields. Flip solver worked with fields and points, but the particles are just points. We don't have fields. So we are going to add this curve force here to make it suitable for particle simulations. We are not going to edit the sub guide here because the sub guide here creates our force, and we are just going to edit this gas field VOP. We will no longer use this gas field VOP because it works with fields. We are just going to use a pop VOP here, and in this pop VOP we will just do the same here in the inputs. I can copy this and copy this one too. And now here we can copy all of the nodes from this gas field VOP. We can here in this pop VOP, we can paste all of these nodes like this. So let me now connect the position here to the position of the particles in this volume sample V, and the file is here. We're doing the same thing, but instead of the position of the voxels, we are now accessing the position of the particles. It's the same thing if you think about it. And the PC open, we're going to connect it here and here. So now we here in this pop VOP, we don't deal with fields. So now this bind here will is not going to do anything. It's just going to search for an attribute on these points called vel, and is not going to deal with the fields. In the gas field VOP, when we binded a field here with the bind node, or when we just created a bind node, we just if we just set the name to velocity, it's going to grab a field. But here the bind node grabs attributes from the points. So we already have the velocity here as v, not vel. So either you rename this vel as v, or you can use the velocity here of the particles instead. So connect it here and connect it here, and finally here also we can now delete this vel and delete this vel. We can export this as our particles velocity. So if we now connect this pop VOP instead and set the curve's thickness, yeah, we can set it something like 0.5, 0.5 like this. If we now play our simulation, it's not working. Why it's not working? Let me see. We are doing everything as it should be. Position and velocity. No, I changed the curve thickness in the gas field VOB instead of the pop VOB. I'm sorry. And here we go. We should have everything working now, but it's not working. So I realized my mistake here. I chose the passes here wrongly. This is the DOP network 2, and this node is curve force 1 subguide, and here out velocity, and then our curve. Okay. Now if we play, we should have it working, and yeah, it's working now. So this is how you can apply a curve force for the particles with the same controls. So what we did here is just we did the same process, but instead of velocity field, we connected this velocity, and now everything is working fine. So thank you guys for watching. This was the example of creating curve forces in Houdini. And of course, you can use either the pop version or the field version to manipulate fluid simulations. As we said, fluid simulations work with both the fields and the points. Okay, thank you.